Okay, so relative frequency, they're a way of working out probabilities, and they're not actually theoretical. It's more of an experiment where you can actually calculate the probability based on some data that you've got. So in the first one then, we've got Josie wants to test if a coin is biased and she flips it 30 times. Here are the results. Complete the relative frequency table. So we basically just want to know the probability for the data we've been given. So the relative frequency, because she does it 30 times, straight away we know it's going to be out of the possible 30 as our probability. So our answers are going to be something out of 30. We then just need to work out how many were heads. So heads, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. 22 out of 30 would be the probability for getting ahead with this experiment. And then tails are going to be the others, but we should then know there's going to be 8 because there are 30 there, but let's just show it. 1, 2, 3, 4, 5, 6, 7, 8. So remember in the exam, just double check so you've not made any mistakes. So it's going to be 8 out of 30. Now, the question B to it says, do you think the coin is biased? So if you think about theoretically, so theory, the probability of getting a heads, probability of a heads is 1 out of every 2. So a half, 1 out of 2. If we did it 30 times instead of just 2 times, 1 out of every 2, how many times do we expect it to be a heads? So to get from 2 to 30, we'd be timesing by 15. And 1 like 15 is 15. So realistically, or just think about it logically, according to theory, it should land on it 15 out of the 30 times. So if we look at our data, the data is heads is 22 out of 30 and the tails is 8. So there is a difference between the two. Heads is showing more likely from the experiment. So if you wanted to explain your answer, you could say that you think that the dice is biased, not the dice, you think that the coin is biased because it should land on a heads 15 times out of 30, but instead it lands on 22 out of 30, so it lands on it more than you'd expect. Although some people would argue it's only been done 30 times, so you could do with repeating the experiment more to be sure. If we just look at the final part to that question, so the final part to that question says, Josie decides to flip the coin 150 times. Calculate an estimate for the number of times it will land on tails. So currently it lands on 8 out of 30 for tails, but we don't want it 30 times. We want to know what if we did it 150 times. So instead of being out of 30, we want it to be out of 150. How do you scale up 30 times something to equal 150? 30 times what would give us 150? So have a little think about it, or think about your 30 times table. 30, 60, 90, 120, 150. So that's going to be times by 5. Equivalent fractions, you have to do the same to top and bottom. 8 times 5, 40. So 40 out of 150 times, we would expect it to land on a tail, so that would be your answer for that question. Let's have a look at a slightly different question, slightly harder. So another relative frequency question. David and Becky want to estimate how many yellow beans are in a tub of 500 jelly beans, and they do a trial, and a jelly bean is chosen at random, and they note the colour and then replace the jelly bean back into the tub. So we've got the information there. Write down the relative frequency of David taking a yellow jelly bean. So it's David and a yellow jelly bean. So yellow is 3 times, and it says the number of trials he did, so this is, all of this is for David, 3 times out of the possible 20. So it's testing can you read the table. Write down the relative frequency of Becky taking a yellow jelly bean. So this one's for Becky this time. So we'll change to blue. So Becky, she has 11 yellow out of the possible 100 because she does her trials 100 times. Whose experiment gives the more reliable estimate for the number of yellow jelly beans in the tub? So this is just a simple explanation needed. Becky's is more reliable, so it's going to be Becky because she did more trials. Becky did more trials. Always say in the exam, like the bigger number, so the more times you do an experiment, the more accurate the data is. It's quite logical. If you test something twice and then you test something 200 times, if you do something 200 times, it's going to give you a more accurate piece of information to work with, because your first two you might not really be getting into it. For example, if it was playing football, you're not always going to get every goal in on your first two, but if you had 200 goes, then you're going to have more data to deal with.